Alright, so what we're going to be doing today is we're going to be looking at solving equations and mainly talking about solving one-step equations and then two-step equations. Okay, so we're going to start off with one-step equations. It's called a one-step equation because there's only one operation that is used to change the variable in the problem. So, for example, you may have something like 3x equals 12. The one operation needed is to change multiplication and do the inverse of that, which is division. So we're going to be talking about a lot of the word inverse, which is an opposite operation, or in math we call it the inverse operation. Okay, so our first example, we're going to look at x plus 9 equals 14. First step is always to draw a line. Again, this is my method that I teach in my pre-algebra course, and it's just to keep yourself organized and keep everything going straight up and down. Next thing we do is we do an inverse operation. What that means is we're going to do the opposite operation of whatever's happening to x right now. Right now, what's happening to x is we have adding 9. So the inverse operation to that, okay, so we're going to do the opposite of that addition, which is subtraction. Okay, so opposite, or like I said before, inverse is another word to use to represent the operation. Okay, from here, the 9 and the negative 9 are going to equal 0, so you're going to 0 out, and that's going to leave you with only x on the left side of the equal sign. Bring down my equal sign, and on the right side, 14 minus 9 equals 5. Again, this is obviously a review for you guys. At that point, the way we would check our answer, and we're going to just practice this check for right now, it's a good habit to have, but I'm going to show you how to correctly use it. You just take that number and you replace the x with empty parentheses and put that number inside of there. So 5 plus 9 equals 14. You'll notice in the notes that I already have these examples filled out for you, but I did want you to do the check because that might be something that you haven't practiced before. As long as it all works out, you know that your answer is correct. All right. So next example here we're going to look at is a subtraction problem. Again, this is in your notes already. So draw our line. Inverse of minus sign, inverse of subtraction is addition. Cancels out on the left side and leaves me just z. And 8 plus 2 equals 10. Okay, from there, really quick to check, we're just going to have parentheses minus 2 equals 8. Put our 10 in there, make sure 10 minus 2 equals 8, and it is correct, and then we know our answer is right. Okay. Moving on to the next example, we're going to go ahead and take 7y equals 42. What I want you to remember is that really means 7 times y. A lot of times people forget that that's a multiplication problem. So when we identify it, we're doing the opposite of that multiplication, which is division. 7 divided by 7 equals 1. So we're left with just that one y left over. Bring down my equal sign. 42 divided by 7 is 6. Checking my answer, I'm going to say, is 7 times parentheses equal to 42? Is 7 times 6 equal to 42? Yes, it is. And the last type of one-step operation is division. This is one that people have a lot of trouble with because there isn't a division symbol in there. So my recommendation is anytime you get a problem like this, rewrite it as simply w divided by 5 equals negative 10. Okay, that way you can notice the operation and easily do the opposite, which is multiplication. 5 division 5 times 5, that's going to again equal 1. And you're going to get w equals negative 50. A lot of times what will happen is you'll have a problem like negative 10 because if you were to divide it by 5, it would work. So you have to be very careful. This is where the check really comes in handy. If, for example, you messed up and got 2 on this one, 2 divided by 5 would not equal 10. So in this case, we'd have negative 50 divided by 5, which is, in fact, negative 10. Okay, so you guys have done one-step equations before, and you've done two-step equations as well. The part that I really want to make sure you focus on, though, is practicing these two-step equations and looking out for some of the common mistakes students tend to make. So, as you know, with a one-step equation, there's exactly one operation to do. With a two-step equation, there are two. So we want to make sure that we're careful on that. And again, it's the same thing as before. We're undoing what's already been happening, so we're using the inverse operations. Okay, our first example, and this is one that's already in your notes as well, so you can just follow along. We're going to go ahead and draw our line, so you can add that line to your notes. Okay, now here we have two operations occurring. Okay, we have this operation right here, which is basically a multiplication, and then we also have a second operation, which is this right here, which as you can see is addition. So normally when you think about the order of operations, you're going to think, oh, I need to do multiplication first. But with equations, we're undoing something. So we're actually following sort of backwards the PEMDAS, and so we're going SADMEP. We're going backwards to the normal way. So the first thing I need to do is I need to eliminate that addition part. Okay, because we're going the inverse, going the opposite operations. So here, I've got my positive 2 and my negative 2, which are going to cancel each other out and make 0. That leaves me with negative 3x on the left side, and 14 minus 2 equals 12. Now we perform the opposite operation of multiplication, which is dividing by negative 3. On the left side, the negative 3 and negative 3 divide out to make a 1. And on the right side, 12 divided by negative 3 equals negative 4. Okay, the last step again, and it's on the paper for you. The rest of the stuff's already done. I'm just drawing the slash marks and stuff, is to go ahead and check it. Now all I'm going to do is I'm going to replace that x in the original problem with a parentheses. Notice everything else is the same. Inside that parentheses, I put the answer I received from my problem, and I double check. Negative 3 times negative 4 is 12. 12 plus 2 is 14. Yep, we're good. That means my answer is correct. And this whole idea of circling your answer and everything like that, we're just trying to get you to build into some organization into your system. So I understand that might be different than what you've done in the past, but we do want you to circle your answer in our class. So on the right side where it says practice examples, I know it's a little weird because the next thing on your paper is another example. I want you to hop over to the part where it says practice examples, and I want you to use one of those empty 10 spaces or so to try out this problem. So go ahead and hit pause and try the problem out using the same method we just did, and when you feel like you've got it done, hit play. Okay, so the first thing we're going to do is we're going to go ahead and draw our line. We're going to add 2 to both sides. Okay, the 2 and negative 2, the minus 2 and the positive 2 are going to cancel each other out, which is going to leave me 4w equals 36. The next operation is to divide by 4, which leaves me w equals 9. Okay, and to check the answer, I'm just going to replace in there with 9. 4 times 9 is 36. 36 minus 2 is 34. So we're good, and our answer is correct. Okay, and another one of the blank spaces. Go ahead and try this one. Pause, hit play when you're ready. Okay, so we're going to go ahead and start off drawing our line. The next thing I'm going to do is I'm going to subtract 7 from both sides. And I'm doing that because I need to create an inverse, sort of cancel out this right here and make it into a 0. I've done that, so I'm left over with 5x equals negative 10. A lot of you have been having issues with positives and negatives. Remember, this is like 3 minus signs and 7 more minus signs. That all together makes 10 minus signs. So you have to be very careful not to get that confused with 3 minus 7. Lastly, I divide by 5. That creates a 1, and I'm left with negative 2. Okay, plugging that negative 2 into our original equation, I'm going to get 5 times negative 2, which is negative 10. Negative 10 plus 7 is negative 3. So we're good, and our answer is correct. Okay, one last one to try. Hit pause, hit play when you're ready. Okay, so first step, I'm going to go ahead and draw my line. I'm going to do the inverse of this piece right here, which is to add 4 to both sides. That's going to give me 7s on the left side equals 21. Dividing by 7, I get s equals 3. Okay, so now I'm going to plug that 3 back into my original equation. 7 times 3 is 21. 21 minus 4 is 17. So we know our answer is correct. Okay, so now the next example we're going to look at is involving two operations again. The first operation we have right here is division. And we also have, as you can see, subtraction. So similarly as before, we're not going to deal with the division first. We're going to deal with the subtraction first by doing the opposite operation. So I'm going to draw my line, perform the opposite of negative 3, or subtracting 3, which is adding 3. Those are going to turn into 0. I'm going to rewrite, again, remember we talked about before, I'm going to rewrite x slash 4 like that into x divided by 4 to remind me of the operation. I'm then going to do the opposite of that division, which is multiplication. That as well cancels out. And I get x equals 32. Plugging that answer into the original problem, I get 32 divided by 4, which is 8. 8 minus 3 is 5, and I'm good. Okay, again, the mistake most people make here is they would have ended up with x equals 2. And what would have happened then is down below, you would have had 2 divided by 4, which would have been 1/2, and that wouldn't have made a lot of sense.